Welcome back, everyone. In this video, we're going to be continuing the theme of finding the derivative of different types of functions. And in particular, in this video, we're going to be finding the derivatives of products and quotients. And you might recall the sum rule. The derivative of a sum is the sum of the derivatives. And I can just distribute that derivative sign to f and g, and that's a fairly intuitive and easy rule to use. Now, unfortunately, the derivative of a product is not the product of the derivatives. I cannot simply distribute the derivative sign to f and g. And same thing with quotients. The derivative of a quotient is not the derivative of f divided by the derivative of g. They're going to be different rules for both of these situations. And the derivative rules for these two types of functions are called the product rule and the quotient rule. And as for where these rules come from, once again, much like with the power rule, I'm actually going to leave it out of this video because there's already an excellent video by 3 Blue 1 Brown that uses much better pictures than anything I could create. And so I'm going to refer you to that video if you want to know where these rules come from. And in this video, I'm going to stick to what the rules are and how to actually use them. We're going to start with the product rule. And again, this is when you're taking the derivative of a product of two functions. So if you have one function f times another function g, how do you take the derivative of that product? Well, that's the derivative of f times g plus f times the derivative of g. That's what that little prime symbol means. Once again, that is the derivative of that function. And so we have the sum of two terms, both with f and g in them. And in one of the terms, we take the derivative of f, and in the other term, we take the derivative of g. Now, due to multiplication and addition being commutative, you could rearrange these terms in different ways and still get the same answer. So if you've seen this in a different class or in a different textbook, presented a little bit differently, it's still the same thing, and it doesn't matter which one you use. So as an example, let's find the derivative of x times e to the x. I know I have to use the product rule because this is a product of two functions. This is the function x multiplied by the function e to the x. And so using the product rule, we're going to be taking the derivative of the first function, which is the derivative of x, and then times e to the x just left alone, and then plus x left alone times the derivative of the other function, that being the derivative of e to the x. Now to finish this off, let's actually take the derivative of x, which is 1, using the power rule, or you could think about it as a linear function with slope 1. In either case, the derivative of x is certainly 1. And the derivative of e to the x is e to the x. It's that function that it is its own derivative, and that's always a nice one when it shows up. And so the derivative of the product, the derivative of x times e to the x, is e to the x plus x e to the x. Let's do one more example, and let's find the derivative of the function square root x times 1 plus 2x. And in this example, I actually don't need to use the product rule. I could distribute that root x to both 1 and 2x, and then take the derivative using the power rule. Now this is also a product of two functions. This is the product of the square root of x times 1 plus 2x, and so we're going to use the product rule just so we can get another example of how to work through this process. And so we're taking the derivative of this product, but before I even use the product rule, I'm going to rewrite that square root of x as x to the 1/2. Because that's what it is, and it tends to be easier to work with these square root functions when I write them as power functions, when I take derivatives. But once I have it written like that, I am ready to use the product rule. And once again, the product rule is the derivative of the first function, which is the derivative of x to the 1/2, and then multiplied by the second function just left alone. And then we add to that the first function multiplied by the derivative of the second function. Now to finish this off, we have to actually take the derivative of those functions. And so the derivative of x to the 1/2 using the power rule is 1/2 x to the negative 1/2. Because using the power rule, I brought that 1/2 down in front, and then I subtracted 1 from the power, and 1/2 minus 1 is negative 1/2. And then on the other side, I'm taking the derivative of 1 plus 2x, and the derivative of 1 being a constant function is 0. And the derivative of 2x is 2 using the constant multiple rule and the power rule. And so the derivative of our function is this lovely answer down at the bottom. And if you look at this, don't feel the need to simplify it in any way. By this point, you've taken the derivative, and if that's all we ask, you can stop here. You don't need to do any more with it. This is a perfectly good answer. Next, we're going to move on to the quotient rule, which is when I'm taking the derivative of a quotient of two functions. So if I have one function f divided by another function g, how do I take its derivative? Well, its derivative is equal to the derivative of f times g minus f times the derivative of g. So in the numerator, it sort of feels like the product rule, except you have a minus sign instead of a plus sign. And in the denominator, we have g squared. And I think this one is tough for a lot of people to remember, just a lot of pieces to keep track of. But with enough practice, you will get this down. You have to repeat it over and over in different types of problems, and then you'll get it. And as an example, let's take the derivative of x squared plus x minus 2 divided by x cubed plus 6. I'm definitely using the quotient rule here because I have a quotient of two functions, my numerator being one of the functions and the denominator being the other function. And so just following the rule above, we're going to take the derivative of the numerator, which is the derivative of x squared plus x minus 2, and then just multiply that by the denominator left alone, and so that's x cubed plus 6, and then subtract just the numerator left alone, which is x squared plus x minus 2, and then multiply that by the derivative of x cubed plus 6. And all of that is being divided by the denominator squared, and so that's x cubed plus 6 squared. And once again, like with the product rule problems, we have to finish this off by actually taking the derivative of the things that in the previous step we said we would. And so let's take the derivative of x squared plus x minus 2, and using the power rule, that's going to be 2x plus 1, and then the derivative of negative 2 is 0, and so in total the derivative of that quadratic is 2x plus 1. And then on the other side, we're taking the derivative of x cubed plus 6, and once again using the power rule, the derivative of x cubed is 3x squared, and then the derivative of 6 is 0. And much like the last problem, you do not need to do anything with this. You do not need to simplify it or multiply anything out. Leave this as is. This is a great answer. Now let's do one more example just to give you a variety of examples to model your work after. And so let's take the derivative of e to the x divided by 1 plus x squared. And even though the quotient rule is not the easiest rule to use, it's certainly easy to identify. We very clearly have a quotient of two functions, and so we can't be using anything other than the quotient rule. And so the derivative of this quotient is the derivative of the numerator, which is the derivative of e to the x, and then multiplied by the denominator left alone, which is 1 plus x squared, and then subtract the numerator left alone, which is e to the x, and then multiplied by the derivative of the denominator, which is 1 plus x squared. And then all of that is being divided by the denominator squared, which is 1 plus x squared squared. And finally, let's take the derivative of e to the x, which, as we've said before, is still e to the x. It's that function that is its own derivative. And then on the other side, we're taking the derivative of 1 plus x squared, and the derivative of that is 0 plus 2x, using the constant rule and the power rule. And leave this alone. This is a great answer. You would stop here. Now there might be times where it's in your best interest to simplify it. Say if we ask you to find the equation of a tangent line, and maybe it'll be easier to work with if you simplify it, but you never have to.